is Miss Scott, coming to you for a first video in a series of videos to review some of the topics for our first chemistry-based exam in physical science. If you are not in my physical science class and you have found this video, I hope it is useful to you in some form or fashion in your endeavors in life. Alright, here we go. So, what are we doing for this video? Here's our goals for this video. By the end of it, you should be able to identify the subatomic particles and their characteristics, and use the periodic table to determine the number of subatomic particles in each atom. So get to know who we're dealing with and find out how many of them there are. Alright, so we'll start here with this little organizer I've made for the 3 subatomic particles. I want you to know their charge, size, where you find them, and what that particle does in terms for the atom as far as what does it make. It doesn't make an element, ion, etc. Alright, so first particle we'll talk about, our good friend the proton. The proton has a positive charge, a positive plus sign. That's easy to remember. Alright, protons have relatively, and I say relatively, because we know atoms are really super small. They're the smallest basic units of matter. But in terms of other atomic parts, the proton has relatively large mass. Most of the atom's mass is partly due to the protons. Alright? The proton is located in the nucleus of the atom, and the nucleus, if you don't know what that is, it is just like a nucleus in a cell for biology, in that the nucleus in the cell is the control center. The nucleus is the center of the atom. Alright? And protons, what do protons help us determine for our atoms? Protons tell us what element it is. So you've heard of the periodic table of elements. Basically, all atoms are made up of the same 3 kinds of parts. It's the proton number that determines what you are. So if you're a carbon atom, you have 6 protons automatically. If you're a lithium atom, you have 3. If you change that proton number, you change what element you have. Right? So those are our friends, the protons. The neutrons are next. Neutrons have a neutral charge, which is easy to remember because they kind of sound the same. Neutral, if you don't know what I mean by that, it's no charge. So I just draw a blank circle, 0. Not positive, not negative. The size, again, like the protons, they are relatively large. In relative, for an atom, which is really small. Relatively large mass. So not necessarily takes up a lot of space, but gives it a lot of weight, if you will. The location is also in the nucleus, also in the center with the protons. There's actually a reason why it's there. Protons, if you know anything about electricity or magnetism, you might have heard like repels like. Kind of the opposite of birds of a feather flock together. Basically, positive charges don't like being near one another, so they'll try to push away. They will repel one another, which is bad for us, because then your atoms are just falling apart. The neutrons emit a force, it's called a strong force, and it holds these protons together when they don't want to be together. So, neutrons are really helpful. All right? Elements, so you can have 2 different carbon atoms. They both would have 6 protons, but they could have different numbers of neutrons. One could have 6, one could have 8. And what that changes is the isotope. So when we talk about nuclear chemistry and our nuclear topics, we'll talk about stable isotopes versus unstable isotopes. It has to do with the number of neutrons that it has. And lastly, we have our friend the electron. The electron has a negative charge, minus sign. So it doesn't sound the same, which might not be helpful to you, but if you need something to help you remember, electron, that has to do with electricity, like being electrocuted. Being electrocuted is not a good thing. It's a bad thing to be electrocuted. I don't want to be electrocuted. I hope you don't either. So that's how you remember that. The size of the electron, relatively small compared to the others. So when we look at the size, we really had to compare them to one another. Protons, neutrons are really big compared to the electron. The electron almost has no mass. Almost none. It's still there, but but just barely. All right. So where do we find these super tiny elusive electrons? We find them in orbitals around the nucleus. So they're not in the center with everybody, they're on the outer edges. The Bohr diagram, or the Bohr model of the atom, shows that electrons orbited like little planets in a set path. We know that's not 100% accurate, but it's a good way to draw it. So this was the nucleus of your atom. Here's all your protons and neutrons, all tightly packed together. The electrons would be out here. And when we talk about ions, go see the ion video. That tells you where the electrons have to be. It would be way out here. And if you want a scale for this, we typically draw it on this scale. But in all reality, it's much greater than this. If you were a proton or a neutron in the nucleus of an atom, say a lone particle, your closest electron would be like half a mile away from you. So there's lots of space in an atom, which is kind of weird to think about. You think of something solid like a table or a chair or a desk or whatever, your computer. Most of it is empty space. Because that's just how atoms are built. All right, so we have the particles that we care about. There's other particles aside from this, but we don't get into that. But watch the cosmos for that fun stuff. Now we want to figure out, all right, I know who I'm dealing with. How do I figure out how many of them I have? That's important. That's helpful. So I will draw this little square. Hopefully you have a periodic table in front of you, or around you, or somewhere near you. That's helpful, because that's all we're talking about. Basically, the periodic table is a great big reference chart that is organized in a way that puts certain elements together because they act a certain way, and there's all these trends regarding how they act and sizes and react and all that good stuff that we won't get into this video. But each square has information about each atom. All right, we will start here. Your letters, that's just your symbol. That's what you would use in a chemical equation. If I'm talking about lithium chloride, I don't want to write out lithium chloride every time. I just want to abbreviate Li. This number right here on my periodic table in my classroom is actually in the upper right-hand corner. I've seen some that I have it in the lower left-hand corner. I've seen some that have it kind of over here, or there. It might be different on each periodic table, but there's always going to be a whole number. What that is, that's your atomic number. Your atomic number is important. It tells you how many protons you have. So every lithium atom, remember, the protons tell you what element it is. In every single lithium atom, there's going to be 3 protons. Not one more, not one less. Always going to be 3. Always. In a neutral atom, and be careful with this because most atoms aren't neutral in their free state. They don't like being neutral. And we'll talk about that with ions. But in a neutral atom, and I'll make a note of that, the atomic number is also going to be your number of electrons. So what I mean by neutral, and if that's still kind of blowing your mind, I'll draw a picture for you that would help. In a neutral atom, all your positive charges get canceled out by negative charges. So in order for that to happen, I have to have the same number of both. So that would cancel that, and that. No charge overall. Again, most atoms, unless it's a noble gas in the very far right column, you're not going to see this a whole lot. Okay? Our last number we're dealing with is this one down here. This one is almost, and I say almost, always going to be a decimal, and it will be the larger of the 2 numbers. What this is, That's your mass number. And what a mass number is equal to is the protons plus neutrons. And you might be saying, well, how do you have it as a decimal then? How is it a decimal? Can you have 0.941 of a neutron or of a proton? No, you can't. What this is an average. So we look at a bunch of atoms, and we say most of the time it has about this many protons plus neutrons. Some are a little smaller, some are a little bigger. What this is useful for is we can use this to determine how many neutrons we have. Because I already know how many protons I have. It's up here. All right. So there's a couple steps. This is the only math that we're doing in this video, and it's not very hard math. What it is to do, step 1, so how to find the neutrons. Step 1, we have to round this number. We have to make it a whole number. Round the mass number. So round the mass number to the nearest whole. That's an E. There it is. All right, so 6.9, rounding lesson. If this number right here, look at that one. If it's bigger than 5, round it up. If it's smaller than 5, round it down. So 6.9 would round to 7. That's my round to mass number. You would subtract. And this number now, once you round it, is called the atomic mass. Subtract atomic mass minus the atomic number. Because again, mass number is basically protons plus neutrons. The atomic number is protons. So you're taking protons plus neutrons and subtracting protons. So all you are left with is neutrons. So in this lithium, I would take away 3 because I know each one has 3 protons. And I end up with 4 neutrons. All right, if you want to do another example of that, pick any, I mean, you can do this with any element, really. No sense in why you can't. But I will choose hydrogen, because that's one that everybody freaks out over. Hydrogen, 1.00, I think that's a 7, I can't tell. Okay, line is bad. All right, so each hydrogen has 1 proton. It's got 1.007 protons plus neutrons. So I round the mass number, 1.0. If I have $1 and like 7 thousandths of 1 cent. I have $1. That's all I have. I don't have closer to $2. All right, so that would be 1. Take away how many protons you have. Minus 1. Oh my goodness. A normal or an average hydrogen atom has no neutrons. Ooh. And that's okay. That's okay. And that actually makes sense for hydrogen. If you only have 1 plus charge, it's not trying to get away from any other protons. So it would make sense that it would have no neutrons. There are isotopes of hydrogen that have neutrons. There's one that has one neutron, a mass number of 2. Tritium is a fun isotope of hydrogen that has 2 neutrons. It has mass number 3. That is what is used or was used in the first hydrogen bomb that the United States tested. That was the fuel used. So, if you have any questions about what we just went over in this video, comment below, and I will get back to you as soon as possible. Till then.